Founded in 2010, SOAR is a student-led high school enterprise team from Dollar Bay, specializing in ROVs. SOAR allows students to gain experience in areas such as coding, design, electricity, manufacturing, and troubleshooting. Each day, challenges are taken on, where failure happens often. We embrace our failures and learn how to move forward.
When you first join the team, you are what we call a rookie. Every rookie starts with the same project. With a $400 budget, you design and create an ROV that has to grab a T from the bottom of a lake. While doing this project, you learn how to do budget, design parts, problem solve, and compromise with your team before moving on to more difficult projects. You can also get a chance to learn what you like doing, whether it's designing 3D prints or doing the wiring.
As a rookie, you also create your own watertight camera. To buy a good quality camera that does what we need is expensive. The ones that would fit within the $400 budget are not reliable and not good quality. By making our own, we can use a high quality camera and also be exposed to the engineering and manufacturing process through creating a watertight design. During this process, we will also learn how to read an O-ring design standard and apply it by deciding how deep and wide we make the grooves.
A project we've been working on at Dollar Bay Schools is our demo ROVs. And our demo ROVs are really used for the community to get kids and other people used to robotics and get them introduced into robotics. These ROVs are used mainly for kids, and they're used with a NES controller because it's familiar and people are more used to using them more than a standard blocky controller. So over the years, we wanted to make the system easier to transport and make it more mobile. But we ran into a problem. It wasn't very secure. The batteries weren't very secure, and the box was very clunky. So in school, we designed and made parts in OpenSCAD to make it more compact and more mobile and be able to, so we can carry it around easier.
One of the biggest challenges we would face is when something broke on one of our ROVs. It was hard to replace it because of the connectors. A majority of the time we'd have to replace multiple clamps, but now with the new dovetail connectors, we can easily replace and fix broken parts on the robot. Our new design also doesn't require any tools, allowing us to easily swap out parts and take away the risk of dropping tools into the water.
Our goal for the Isle Royale ROV is to make it easily repairable, durable, and multi-purpose. Most of the structural parts are 3D printed, making replacing them very easy. The pins are small and light, so if one breaks, you can have replacements with you in the field. Another advantage to 3D printing is you can manufacture your own parts. You don't have to wait for things to ship, which is especially important in the UP because we're so far away. One of the latest improvements we've made on our ROV is refining our backplates. Our old backplates were made by epoxying the wires in between two pieces of acrylic plates that squish the wires in with epoxy. These are bad in many different ways because they're really hard to troubleshoot. The wires are locked in place, so you cannot easily repair them. You cannot individually disassemble wires, and if you find an issue, you will have to replace the whole backplate. Our new design uses Dutch connectors that are epoxied in place. This is better because you can independently unplug each wire to troubleshoot and easily replace bad wires because they aren't locked into place. And this backplate looks so much better, more organized and professional.
The SSROV, or buoy, is our only ROV that does not run a tether to land. There are a couple advantages to it. With other ROVs, they would drift with the boat because of their tethers. But with buoy, since there is no tether running to a boat or to land, it can't be dragged. And since it has such a low profile to the water, it's less likely to be affected by the wind. Also, with our other ROVs, once they're underwater, you have no idea where they are. There have been times where we thought it was on one side of the dock and it came up on the complete opposite side. With the ROV under buoy, you always know where it is. It's always straight under buoy. But since buoy is such a large project, we split it into two teams, the surface team and the underwater team. I work on the surface team. I've worked a lot on how to deal with jams. The gray piece on the top of buoy is the hoist, which controls how far below buoy the ROV is. But with the hoist, we also run the risk of jamming it. Buoy runs a code that constantly compares the current from the hoist to a preset jam current. If the hoist current ever goes over that number, buoy will reverse the hoist to try and undo the jam. When buoy is jammed, the light on top will also blink quickly to tell the operator. So if the reverse happens and the light's still quickly blinking, you know that buoy needs to be brought ashore and unjammed manually. The light also helps communicate if the ROV is secured up beneath the buoy. The light will blink at different speeds to show different things, and is also constantly blinking to let vessels on the water know that buoy is there.
My job with the buoy ROV is designing the underwater portion, which is the sealed tube with the camera. Some of the elements of the ROV that I've been working on have been Arduino code, just manufacturing in general 3D printing pieces, making parts, and the video feed, the live video feed wirelessly. A big problem I have faced working on the buoy ROV has been control. Previously, it was controlled with big aircraft remotes that don't have all the levers and knobs that you might necessarily need. So we ended up using 2 remotes. 2 remotes is difficult because you need 2 people and they have to communicate well to properly operate the ROV. The solution we came up with is using a PS2 remote that we're very familiar with using, and we already have a lot of the code designed to transfer this into something that we can understand for our motors. But the problem is this is wired. The buoy ROV needs to be wireless. So I have been working on making something that will plug into this and turn it wireless signal, and then it can be sent to the buoy, and then the buoy can turn that signal into actual instructions for the motors and ESCs to follow.